Okay. Okay. So 7.1, what is the actual name of this chapter? The actual name of this chapter is what? Inside atoms. Okay. The full name of the chapter is Inside Atoms, because this is what you will see on each page on top. Yes, inside atoms. Even here, inside atoms. So this is what we are going to study now. Okay.
Okay.
Now inside, now what is atom basically? It is the smallest structure for any thing. Now when we zoom in, oh, my board is now connected. Okay, so what I was telling, if you zoom down to any object, okay, either living or non-living, you will come across what? The smallest structure will be known as atom, and within atom you have some more items. What? When you will zoom in, you will get, oh, what's the issue here? Yes. So when you zoom in, you will see something like this. Okay. When you go to the microscopic level, you will not see this. Yani this is just imaginary. Okay. This orbit is imaginary. But what will you see? You will see at least three type of different structures. One that is rotating like this, yani revolving around the center. Okay. These are known as electrons. Am I audible?
Yes, Mister.
Because when I don't hear any interruption, I think I'm not audible. Because you guys want to interrupt. Ratul. So this is
Why?
electrons. What why? It's proven. See my recording. See 20 records and tell me in which one you guys don't interfere. Within 10 seconds I start the class. What will happen later in your life? Now you are 13, 14 years old, you want to interrupt every now and then. So at the center you will have protons along with neutrons. Protons have a positive charge in them. Electrons have a negative charge in them. And neutrons are neutral. They don't have any charge. Okay. So this is basically the structure of atom. And it's given here also. It's given here also. And how they are like, what are their names? What are their properties? We are going to study those things. Okay. So let's start inside atoms. Have you ever watched or played snooker, pool, billiards? The balls are solid spheres. Yes, I have played it lots. You guys want to see?
Mister, it's called in Arabic billiardo.
Billiardo, I know, billiardo you call it. I'll show you something. Wait, it's my time. Do you guys see something? Do you guys see something?
Yes.
Yes.
This is like when I was like not even teaching you, it's before that. It's in, I think Nariya, you know Nariya? After Jubal, it's like 100 kilometers there. Nariya village. I used to work in that area. I went for billiards.
See, Mister, the PlayStation logo.
Ah, yes, yes, yes. PS4 was there. This is around, you know what year? It's like 2017 or 18. This year is that. So this
2018.
5
Egyptian,
years ago.
this Egyptian guy is stealing the stick from me. That please, because I am hitting continuously. Have you noticed?
Yes.
I'll show you. I'll show you. I'm continuously from here. Look, I'll show you one last time and then we'll move back to the class. Look, now count the balls. See, you have to hit these balls that do not contain the stripes. Yani you know the rules, right?
Yes,
Either
yes.
you select these type of balls that have white at the hair, known as stripes,
I better.
or you choose the solid color. So I have chosen, I think, solid color. Look. Okay, first solid gone. Now brown color is my second target. Second. Now orange.
There is Mr. the game on the phone for
Third.
the billiard.
Yes, 8-ball pool. Yeah, I have
Yeah.
played hours and hours of that game.
Yeah,
Very
me
good. 3. Then the blue one, fourth. Oh, I'm having the same shirt as the ball. Fifth ball.
Mhm.
I think that was the fifth ball. And then I will try to play a safe ball, but it will go in the hole. I will face a foul now. I tried to play it safe.
Mm.
That was it.
Mr. You can teach us billiard.
I can teach everything, huh? Okay, so let's go back. From where is this balloon sound is coming? Someone is blowing a balloon or what?
I don't know.
No? Or the chair sound? Okay.
No, it's
So
not.
let's go back. Now thinking and working scientifically, blah, blah, blah. No. So completely this structure is known as atom. Yani this all package. Yani if I tell you what is this? Atom. But inside atom, I demonstrated how many things so far? 3. 1, 2, and 3. Yes. These are known as subatomic particles. Okay. So you have atom. And then you have inside atom. Any atom is made up of electrons that are moving and protons and neutrons that are at the center. Okay. And these things are known as subatomic. My screen is visible, correct?
Yes, yes.
Yes.
Okay, they are known as subatomic particles. So, and the center portion is known as nucleus. And if you combine total, if I tell you how many circles do you see at the center? Okay,
8.
I can ask you also that how many centers do you see at the nucleus? And the nucleus is what? At the center, like in biology.
Yes.
You have the animal cell, you have in the center nucleus. You have the plant cell in rectangular shape. At the center, you have nucleus, correct?
Yes.
So similarly here, this is the nucleus. There are 8 circles in this nucleus. Okay. So when was this model created? In 1932, scientists had developed a new model. This is the model you will use. You have already seen it in physics. Okay. So this model that I demonstrated to you just now is almost 100 years old model. Okay. This is so old. Now, the model states that the atom are made up of subatomic particles such as what? Such as proton, neutron, and electron. And the central part is known as nucleus. So in the exam, if teacher asks you what comes in the nucleus or nucleus is made up of what will you guys write? Badr?
Yes, also the Mr. in our class said that
Badr. Don't tell me yes,
Yes.
the mister. Give me the answer.
So the answer is in
What
the
was my
screen.
question? Brother, you aren't listening.
Nucleus.
Or are you listening? What was my question? Tell me.
Nucleus are made of what?
Say it again.
Nucleus are made of what?
Yes, my question is nucleus is made up of what? And your answer is?
Nucleus.
Hmm.
Is made proton and neutron.
Not electrons.
Proton and neutron.
Proton, neutron. Where is it written? On the screen? Or where? Your answer is correct. Protons and neutrons make up the nucleus. Okay. And electrons are inside or outside?
Outside.
Outside,
The
rotating.
Yeah, outside.
So,
Outside.
okay. So proton is positive and
Yeah.
neutron is nothing, neutral, and electron is negative. So when you have one positive, one negative, they will cancel each other. So what
Yeah.
is the overall charge of the atom?
Neutral.
Nothing, it's neutral. Okay.
Hmm.
So for example, in this diagram that I have given, how many protons I showed you in my model?
A proton.
Yes,
4.
4 protons. And how many electrons I have showed you?
4.
So 4 positive, 4 negative. They will cancel each
Yeah.
other. So what is the overall charge?
Neutral.
Neutral. But if there are protons less but electrons more electrons, so what will be the
It will
overall
be negative.
charge?
Negative.
Yeah,
Negative
It will be
charge.
negative.
Negative ion.
And when you have less electrons but more protons,
Positive
more
ion.
positive, so overall charge will be
Positive ion.
positive. Yes, we will study about that ions, the cations and the anions. Now look at the mass. Yani, if the mass of proton is 1 gram, proton is way lighter. Yani 1 gram is so heavy. But for comparison, just think, if proton is 1 gram, then neutron is also approximately 1 gram. But electron is what? 1 over 1000 of a gram. Yani electron is 2000 times lighter than protons and neutrons. Okay, they are so tiny, so small.
Mr. C, the mass
Okay.
like down 0.000.
Yes, and look, even the proton is so light, and we can't even imagine in our head. Can you write this number in standard form in mathematics? That 1.7 multiplied by 10 to the power what?
10 to the power 52.
How 52?
I don't know.
You didn't even count the zeros and you are telling me 52. Leave. That's not the point though. So what did we understand from here? That even the protons are so tiny, so lightweight, but even 2000 times lighter than the protons are what?
Electrons.
Electrons.
Yeah, Mr.
Okay.
This number divided by 2000.
270.
This number, yes, this number further divided by 2000, you will get something very tiny. Whether you are saying something? What happened? No problem. So why do atoms have no electric charge? I already told you, because overall it's neutral, because the more you have equal number of positive and negative. So they cancel out each other. Like what? Look here, 5 positive and 5 negative. So 5 positive will cancel the 5 negative charge, correct? So what is the overall charge? Because neutron will not give you any extra charge.
Neutral.
Okay, so it will be neutral overall.
Yeah.
So that's why they mention here, but they have no net charge. There is no overall charge, no resultant force. Okay, in physics we studied no resultant force. And you have 100 Newton going here and 100 Newton going here. What is the resultant?
0.
0.
0, because 100 minus 100 equals 0.
Yes, in physics we did the bike
Yeah.
and the
but
wind
Mr.
and the
Mr.
wind
question.
example. Ah,
So I have a question.
ah,
If
Taban.
there's if there's 4 positive charge
Ah.
and 5 negative charge, so
Then the overall charge will be 1 negative.
yeah, 1 negative. It will be 1 resultant force.
One resultant force, one negative. Yes. We will study in the following chapters, I think, the overall charges. Now, give the charges for these things. What is the charge for proton?
Plus.
Plus.
Positive. Don't
Yeah,
write plus,
positive.
write positive. Okay. Neutron is neutral.
Okay.
And electron is negative.
Negative.
Okay. Name the type of force that holds an atom together. This we didn't take. What force holds the atom together? I need to check.
So I think we need to read the experiment. Yeah, and analogy. I think it's important.
No, analogy is when I want to explain to you something, I give you an example of a situation. That thing is known as analogy. Okay, like here, they have used the example of pool balls to explain the concept of atom. So this is an analogy. Okay, this is the English meaning of analogy.
Okay.
Like they have showed you that when the ball hits, when this white ball hits the other colored balls, the colored balls move in different direction, depending on the speed, depending on the angle. The same happens with the atoms. When atoms hit each other, they move in different directions. That's what they are explaining to you here. I need to check this one. This question. Name the type of force that holds an atom together. Wait.
It's the last part, mister. What holds an atom together? The nucleus of an atom is positively charged. That one. There's the answer.
Chemical bond is the answer for this.
Wait, what?
Chemical bond what here, yes. And it's written here also. It's also explains chemical reaction. So chemical bond is the answer.
Chemical bond?
Yes, not James Bond.
What is that?
That's the answer. Describe an analogy that helps to explain the size of nucleus compared to its atom. They are asking us an analogy.
Mr. The solar system.
Solar system?
Yes.
Oh, who told you this?
Like I got it from my mind. Like not only
that
my mind.
example looks good. That example look good. Yani you are telling me that as the nucleus is in the center and electrons is revolving around it, the same way sun is at the center and the planets are revolving around it. Okay, this looks good. But they are asking about the size, not the motion. Look.
Size.
They're asking about how can you compare or understand the size of nucleus with the size of the overall atom. Let me check.
Yeah, Mr. The solar system is like the whole atom, and the sun is small to the smaller. No, it's not.
So, Mr. We could say that the electrons is us, and the atom is the whole solar system.
How that works?
Because like the nucleus is so small, but the atom is so big.
Look at the analogy Google is telling. You will be surprised after reading this statement. Look, I'll explain also. They are telling you an example that if the atom, where the size of the atom were, not where, were, is a spelling mistake on Google. If atom were the size of a baseball stadium, okay, baseball stadium is very big. If that was, that stadium is an atom, then the nucleus would be smaller than a baseball. Yani in this stadium, what is the size of a baseball bat? Baseball bat will look like this. Am I correct? Or even I have drawn the bat as bigger.
Yeah, it has to be smaller.
It should be even more smaller, the bat, yes?
Yes.
Yani if you zoom out from space, yani you have the helicopter camera when you see the FIFA matches, yes? Sometimes they zoom out like this. So from this distance, you see the whole ground, yani people are sitting, and then you have the football ground. And how is the ball? like this, one dot like this. Maybe the
Yes.
ball is like this. Yes. So
Yes.
for example, this is the baseball bat. For example, this is the baseball bat. So this is the size of nucleus compared to atom. Look, it's so small. And this is just to make you understand how much difference is. Did you understand, guys? That if you compare the whole baseball ground or football ground to an atom, that compared to that, nucleus is so small that it is almost the size of a bat in a stadium. And if stadium is atom, then the bat will be nucleus. And it's so small. So small. Clear?
Clear.
And Mr. You can say the orbiting of the moon of the Earth. Like the Earth is the nucleus and the moon is the electrons. It's the same because like the Earth is
what?
small and the moon
Earth is what?
like the moon is orbiting the Earth, and
Okay.
it can be the analogy because Earth is small and moon is smaller. Like it can be good analogy.
You are using the electron size.
Yes,
Because electron is very small compared to the nucleus. So you are
Yes.
using the moon. Okay.
So moon is like smaller than the Earth, and
So
Earth
the same you can use for sun and Earth.
Yes, but the sun is so big. Like it's not only a small nucleus.
Okay. So look, the nucleus will be perhaps the size of a ping pong ball. Wow, so small. Let me put it here. Now, draw a beryllium atom. It is made up of 4 protons, 4 electron and 5 neutron. It's also given here. Oh, it's the boron here. How will you draw the diagram? Everyone have notebook?
No.
No,
Okay, bring.
I have to.
Bring, and I'll bring my water bottle also.
Okay.
What is beryllium at? Oh, okay.
I'm explaining. It is a type of element.
Yeah.
But the structure is already given to you. 4 proton, 4 electron, 5 neutron. So quickly draw the nucleus, quickly draw the electron, draw the orbit, and show me the answer on WhatsApp privately.
Okay.
Okay. Have you started making circles? Start making something like this and send me. And remember, the first orbit can contain maximum 2 electrons. Okay. So in the first orbit, don't give me 5 electrons. Are you guys listening?
Yeah.
Don't give me 5. Just give me maximum 2. And the remaining you can throw in the next one, no problem. But the first contains only 2. And the second contains 8.
Yes.
But since this is so small example, you will not need even 8.
Yeah.
Complete and give me the answer quickly on WhatsApp privately.
Okay.
Mister, I have it on my book already.
The answer?
Yeah, can I just send you like on my phone?
Okay. So you did it in the class with the teacher?
No, not with the teacher. I just did it. I don't think we did the questions with the teacher. So should I send you like a picture?
Mister, I have a question. Mister, I have a question.
Send me like a picture. Yes.
Like the protons and the neutrons can be together like in the same place, the circles, or
Yes. They are in the same place. You can use 2 type of patterns. If you are using with pen, you can use 2 different pens. Or if you have a same pen, you can shade something and call it something else and unshade like this. Yani you have to identify something. Okay. Or like you have something like this, you can draw yani a pattern like this, and somewhat is like this. Yani it's your idea.
Yeah,
but the easiest is color them or not color them. This is the simplest. Yani everyone will
Yeah.
understand.
Yeah, Mister, I'll make the neutrons shaded and the protons not shaded and the electrons X.
Okay, but you have to label this thing because the
Yeah,
one who
I'm
is
putting
looking
it
at
up.
your answers, yes,
He
you have
won't
to
know.
explain to him in a corner, in a legend. Okay,
Yeah.
that this thing means this thing means this, and like masalan, this pattern means this, so that the viewer does not have to scratch his head. Ah, Ishada. He should understand instantly. Shu hade. I didn't get any answer so far. Are you guys drawing
Mister,
some
I don't have
Mona
my
Lisa
phone,
or what?
Mister. I don't have my phone. I got sent.
You don't have your phone. Who has phone? Send me.
Wait, let me get my phone. Let me get my phone. I found it.
Of this fast.
The fastest. For real.
Fastest and the furious test.
Mr. Vice.
One करना है क्या? हैं?
Mister, have fun seeing my dark color. The ugliest drawing ever.
After the exams finish, when you have study days, I will start giving you guys homework. I was thinking about it yesterday.
No,
Homework?
Mister.
No, Mister.
The homework for the drawing of things, because you guys are extremely bad in drawing. Huh?
No,
Hanil?
Mister.
Oh yeah, Mister. Yeah, Mister. Make us homeworks on the writing.
I'm coming. I'm coming.
Instead, Mister, make like teach us art.
How can you teach art online? It's so difficult.
Little bit fun.
It'd be fun, but remember, like when Mr. Muhammad Azhar was
Yes,
making
what
us a
I
class.
noticed that your guys' drawing is extremely bad. The handwritings are extremely bad. Now I cannot fix everything at the same time. I will start slowly. Okay.
With the
So I
the
will start
handwriting.
giving you guys with the handwriting.
Yeah, better.
I was thinking with the drawings. Okay, I got 2 drawings so far.
Mister, it's taking a little too long, Mister.
It's too long because you guys never do it. That's the issue.
Mr.
No,
You
Mister,
guys
I only
never
know how
draw.
to
The
do it on
teacher
my
never
book.
tells you.
No,
Look
Mister,
at
he
this
did
good
that.
drawing, Mister. No cap.
Yes. I will give my
Mr.
comments on
Needed.
that.
You did not give my drawing.
This is
Oh,
not,
this is my drawing. Wait, this is not.
no,
my
this is
drawing?
mine.
This is Muhammad Ali's drawing, and this one is Muhammad Ali's drawing.
It
He don't even recognize his drawing. Muhammad Ali. Now let's go to Muhammad Ali's drawing. He has drawn
the worst circle ever.
1, 2, 3, 4, 5. Are there 5 neutrons? How many neutrons are there in beryllium?
Oh yes,
5
yeah,
neutrons
five.
and 4 and 4. Any 4 positive, 4 negative. So
Yeah.
4, okay, 4, okay. Okay, looks horrible, but I'll accept it. This one.
I think I made
Now,
five.
Uh,
I made everything 5, Mister.
oh, so this is technically wrong. Muhammad
Yes.
Ali's was technically correct, but like aesthetically not pleasing. But this guy is not even technically correct. Okay, what's the issue here? Protons, one extra he has created. So I will. Oh, I have an eraser sort of stuff, gray color.
Wow, magic.
Magic. Sahir. Okay, this is gone. Now 1, 2, 3, 4, 5 neutrons correct, and outside 1, 2, 3, and 4, and this is already deleted. This is good,
Yeah.
but
Mister,
no
I
need to
sent you
create.
mine.
No need to create this box. No need.
Because,
Yeah,
This is not
because in the book they are making it, Mister.
where they are
No,
making.
no.
In the review.
Oh, yeah, in the review. But still, يعني.
عادي يعني بقدر share بدل.
Mister, I sent you mine.
No, they are making the box because why? Because they are asking you what is the name of this thing. That's why they have created box, because they're asking you a question there. So your answer in that question will be nucleus. But when you draw a diagram, you don't draw this box.
Okay.
Clear? You don't draw it.
Okay.
Okay. I received one more thing.
Yeah, that's
Mister,
Wow.
my drawing is.
Are
the
you
worst
working
up to
on?
now.
Are you working on PPT or what? How did you give me this? Look at the beauty of the animation. Stick drawing. Green is electron.
Uh-huh.
What
Mister,
didn't
put
you
all
get
caps,
circles?
mister.
Why didn't you get circles from the instead?
I didn't
Yes, you
feel
see?
like it.
You see something?
Mr. Badr
Mr.
is
Badal
flexing.
is showing his food.
He's flexing what type of chocolate he has.
What,
right?
brother? What happened?
He is showing
He's
us
showing
his
his
chocolate.
food. He's flexing
He's showing
his
his
chocolate.
diagram. Show me, show me, show me.
No, not diagram.
No.
Chocolate.
No, it is. No, it is. Badr, show me your diagram.
Then showing
Yeah.
what?
Yeah.
Face.
It's like a diagram. Like you can like you need some like really good eyes to like see inside the atoms, but like
Why the screen is lagging, Mister?
So I think only 3 students are talking. 2 are sleeping.
No. But there is eating chocolate. Adnan is.
Mr. Faiz is gone.
Yeah, that's sad.
I think the
Yeah.
internet has been.
No more math classes.
I think he just like had to get some milk real quick, you know?
It's recording, yeah.
No one will see it anyways. Except me. Oh my god, chocolate. Mr. Faiz is gone.
Yes.
Oh, Mr. is back. Let's go. Hi, Mr. Look at Badr's picture.
You
Screen.
guys,
Camera.
All the chocolates.
you guys
Look
are here.
closer. Yeah.
Yeah. Other than Adnan. He
Yes.
left.
Yes, you guys are here.
Yeah, we
No,
got Badr.
yeah, everyone is here, but Adnan is long gone.
Adnan is gone. Okay, let's
Yeah.
continue. I had internet issues.
No, I'm stuck.
Let me check. Oh, he's there. Who is saying he's gone?
You woke up.
Mr. Badr woke up
My
Adnan.
voice is audible now.
Yes.
Yes.
Oh, he woke up Adnan quickly, huh?
Yeah.
So we were discussing about this beautiful creation. Yes.
Mister,
So-
Mona Lisa.
So green electrons, okay,
Yeah, 4 electrons.
and red protons, 4 piece, okay, and black neutron, 5, 1, 2, 3, 4, 5 pieces. Yes,
Mhm.
this one is good.
Yes, mister, I'm so right, mister.
Did you do this in paint or what? Paint.
is handwriting.
Yes.
Yes.
Mister, I don't know how to write with the mouse. My tablet pen is
Mr.
gone.
Best drawing, Mr.
This is the best drawing. It should be the profile picture of every student today.
Yeah.
It's that beautiful, huh?
I'm gonna put it now.
People will start unfollowing you. Okay, so explain why a beryllium atom is electrically neutral. The photo that you have sent to me, is it electrically neutral or electrically positive or electrically negative? What is the overall
Neutral.
charge?
Neutral.
Mister, it depends, mister.
Neutral.
Neutral. Why?
No, wait. No.
But there's the one, Mr. Let me get this.
Yes,
screenshot.
Mister. It's a
Oh,
neutral
who is showing
because
this? Who is this, brother?
yes, man.
Okay.
MashaAllah. Very good.
Wait 1 second, but let me take the
So
screenshot.
proton is this, neutron is this. Where is electron? Where is the
electrons-
legend? Where is the legend for electron? He's maybe trying to show us the actual electrons. That's why he's zooming that in.
Mm.
Maybe he's showing us the microscopic view of the electrons on his notebook. Yes, brother, let's continue. Okay, let's continue. Okay. So, okay, this is gone.
Now this is the no. I hate this. Listen.
Now discovering electrons. Now, how did human beings find out that there are electrons revolving around the nucleus? Okay, how did they find out? They did several experiments. Now, this experiment is very, very famous. This is known as cathode ray experiment. Okay, now the setup is already shown to you. I will tell you only in like how much the book is telling you, what are the parts and how are human beings able to detect electrons. What is so special in this? I will tell you. Okay. So when was this done? In the 18 inside investigated gases, they took steel tube. This is this. Amazingly, the gases conduct electricity. One day, John. Oh, where are you? Oh, I'm hungry now.
Plum pudding.
Muffin. Oh, pudding.
Looks so yummy.
Yeah.
Okay. Now I will bring one GIF for the cathode ray.
Let's go.
Mr.
Adam and Mr.
Yeah,
Adam
I'm gonna sing.
and Marwan, they drew it
Yeah, I'm
in the
going
class.
to
So beautiful.
Mr. Because Marwan and Adam like are good drawers. So the Mr. in our class, like every time we want to study this lesson, he says for them like to draw it on the board, and they can.
Oh.
And
Marwan
like,
and
almost like it.
Marwan and Adam.
Adam.
Marwan and oh, Adam.
Like Marwan can draw the real face of Messi, Mr. without anything. Like he's so good.
But we should not draw faces, right?
Why?
Islamically, it's prohibited to draw living things.
Really?
Yes.
First time I know this.
Really? I'm
Yeah, me too.
surprised.
I never knew that.
Yes,
MashaAllah,
Adnan.
Allah Akbar. Sheikh
I know.
Adnan.
I know something prohibited, like to wear a T-shirt that have a face on it. But
It's the thing is the drawings that you draw on Yawm al-Akhirah, Allah will tell you, okay, give life to this thing. For example, you created some human being, okay? Allah will bring that photo in front of you and will tell you, Yalla, give life to this thing. Show me if you can. This is the big punishment. And then human beings, can we give life to anyone? No.
No.
So I'll send you the ruling on that. So this is the cathode ray GIF. What is happening? We have a high voltage supply, and we have too much electricity, a high voltage.
Okay.
And then what is happening? We have negative electrode, and this is like an iron bar. I'm telling you in plain words, okay? This is like an iron bar that has overall negative charge. And here you have a positive electrode, means what? An iron bar that has a positive, not iron bar, I mean an electrode, a material that has overall positive charge. So what do you see? When you pass electricity, what is happening? The electricity is going here, and this electrode is doing what? Emitting electrons in all the directions. Emitting electrons. Okay. So what happens? They have a small hole here. Here. This is a small hole. This. Yes?
Yes.
Look. Look now. There is a small hole. So what happens? The electrons that are going up and down, we don't want them. So the electrons that are coming out in a straight line, they will hit where? At the screen here. And what will you see? You will see some light.
Ray.
Yani you will see this area to be slightly like lighting up like this. Look here.
Like a small beam.
Yes, like electricity is passed and electrons are moving in all the directions. But to make them flow in only one straight line, what we did? In a tube, we put a small hole. Otherwise, if we remove this plate, what will happen?
Everything
the electrons will
going.
go like too much.
Yes.
We don't
Yeah,
want
it'll go
that.
everywhere.
Okay, so to make them in a straight line, we make this hole here and then it hits the screen. And what do you see? It's lighting up slightly, fluorescent screen. See, you can see it's lighting every second. Every
But
second
Mr.
it's lighting up. Okay.
What is the function of the positive electrode in this experiment? Like why there is a positive electrode?
To attract it towards itself.
Oh, like to attract the negative
See,
electrode?
negative particles are released from here. These are negative particles.
Yeah.
Negative particles. Where will they go? If there
To
is
the
positive, they will get attracted.
Okay.
Okay.
Now
But now in this GIF, they have used the reverse arrangement. Like here, what do you see?
positive.
Wait, negative electrode. I'll tell you one thing.
But Mr. Like this experiment depends on the element that you are using in this. Like if it was boron or something like that.
Cathode. Negative electrode. Okay, negative electrode. The name for negative electrode is cathode, which is explained to you here. Okay, so the arrangement is not different. I was thinking something else. And this is anode.
And what is this pump, Mr.? Like why is there?
What? Thumb? What is thumb?
Pump.
Pump. Where is the pump?
Up there. Like
here?
Yes.
Maybe to create the vacuum inside. Let me read the description. Maybe to remove the air inside. Maybe. Let me check. So there's sealed tubes containing tiny amount of gas. They set up electric circuit and apply huge voltage. Amazingly, the gases conducted electricity. One day, Johan Hitton noticed a green glow on the screen. So he noticed a green. Oh, they have also used the green color in this GIF. Green. Yes.
Yes.
Green color here. So the glow, he said, was caused by rays from the negative electrode. The rays travel through the gas and hit the screen. These were cathode rays. Okay, so these rays that are coming out, which are negatively charged, they are what? Cathode rays.
Cathode rays. So now, what is the use of this experiment? Like what we should know in this experiment?
See, this is like a development process. They are finding out that there is something in the atom, and that something is creating light. And only this much they have found so far.
Like the electron is the origin of electricity.
Yes. Yani electricity can take place because of the flow of electrons. Yes. So now let's proceed. What do they say? When the voltage is high, the cathode rays travel through the gas. Yani the voltage has to be very high. This experiment cannot work in low voltage supply. Okay, look at even the GIF. It's very high voltage. It has to be very high.
Like Mr. This the high voltage supply have to be a gas, right? Like an element, like gas element.
Which one?
The voltage supply have to be gas element, right?
Gas element.
Yeah, like it has to be.
That?
The element is gas, like or non.
Which element? Which element?
Like boron.
What? You are telling me this material is made up of boron. This is what you're telling me.
No, because the master in our school said that if the experiment, this experiment depends on the element that is used for the supply. Like there are boron that is used to give the supply of high voltage.
Okay, so you are telling me maybe inside they are using boron to create high voltage.
Yes.
This I don't know. Maybe. The reason for high voltage, I don't know how they are producing high voltage, and particularly in this reason. Okay, so I'll ask you a few questions now.
Okay.
Fill in the blank. My first question is fill in the blank. And if I call your name, don't tell me yes, mister. Okay, you have to give me the answer. You don't have to give the attendance. Yes, mister. Ana Mawjood. No. Is it clear? So
Yes,
please keep your eyes open and ears open. If I ask you a question, don't say yes, mister. Please ask me again. No. So the first question is, the positive electrode is also known as, the answers are already on screen. Okay, the positive electrodes are also known as, it's on the screen.
What, Mister?
What, mister? The
I didn't
answer
see
or
it.
the question?
Like,
You want the answer or you want the question?
no, the
It's-
question. There is that.
Yeah, engine.
My question is, the positive electrode is also known as,
Anode.
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 What does
And-
anode mean, mister?
Anode means anode. Yani if I ask you what
Anode
does
means
pump mean,
positive
pump means
electrode.
pump.
No, yeah, what does it do? What does it do?
It attracts the electrons.
Oh, okay. Just like a
Mister, you didn't
magnetic,
ask.
Yes,
magnetic
similar,
field.
almost similar to magnetic. Yes, you can use that analogy. You can use that type of example. And what is the charge of cathode?
It
Negative.
is negative because
Negative. Yes.
electrode.
Yes.
Yeah.
If I ask you what is the charge of cathode, you have to tell me negative. Okay.
But
But
in this experiment, it's a negative charge. There's no positive in it, right?
no, there is, the anode is positive.
see, Mohammed
No.
Ali is not understanding this thing. When you give too much electricity, high voltage to this guy, what it will do to this electrode? What it will do? It will split, and it will split electrons. It will release electrons in all the directions. Clear?
Clear.
But since this is a pipe structure, those electrons that are going above, they get bounced back inside. Yani it's like this inside. Whatever is happening inside, you cannot have it outside now. But because why they are moving in right direction? Why? Because there is a magnet, not magnet. Yani I am using the example only because you have
Yeah.
a positive electrode. That's why that's known
That's
as
why-
anode. That's why these guys are coming here. And because you have a small hole here, you have a hole. Okay.
Oh,
That's why they penetrated and hit here on the screen. And how do
that's
we
why-
know? How do we know that they are hitting the screen? Because they create light. They created green light. This is what you see in the GIF. A green light is being formed. Flickering light. And it like that.
Like, Mister, the positive electrode is captivating the negative electrons towards it, so it will go in the hole to the screen, so it will form a light.
That's why the electrode is negative, because like it went to the positive
Yes.
electrode.
Because
Yes.
if there was, if
Okay.
they were both negative, they will repel each other. They will not attract.
Yeah.
Yes, because same charges repel.
Yes.
So carrying out the investigation now, planning and
Mr.
investigation,
Yeah,
and this
this is
one
important. Planning and investigation is important.
is what?
Important, like
This
to
is
read
important.
or yes, because see the what is written.
So scientist Joseph John Thomson thought about cathode rays. He asked a scientific question. What did he ask? He asked, what are cathode rays? Okay. So Thomson thought about this question. He came up with a hypothesis. What is hypothesis? Yani what he thinks might be the answer. It can be wrong, it can be correct, but he makes a judgment. Okay. He makes a solution result here. And he's checking whether his result is correct or not. So this is known as hypothesis.
Hypothesis. Hypothesis.
Not hypermotion. Hypothesis. Now, as you know, a hypothesis is possible explanation. It is based on evidence and can be tested. Now, what was his hypothesis? He said, and he thought in his mind what? He thought this. He thought cathode rays move towards a positive electrode, so they might have a negative electric charge. Correct?
Yes.
Look, these rays, Muhammad Ali, they are coming out from this metal portion. Yes. This electrode. Yes.
Yes.
Now, they are coming towards the positive guy. This positive. Yes. So, if something is coming towards a positive thing, it means what? That thing itself should be negative. Okay. So, the cathode ray should be negative. This was his assumption. Yani this was his hypothesis. Okay. That's what is mentioned here. Look. Cathode rays move towards a positive electrode. Yani electrodes are of two types.
Positive and negative.
Positive and negative.
Electrode, yes, there are two types electrode. The electrode that is positive, we call it anode. And the electrode that is negative, we call it cathode. Okay.
So, Mr. Cathode ray is negative.
In negatively charged, yes.
Is there anode ray, mister?
I don't know.
Like an experiment that anode rays.
I don't know. Now, so prediction, I need to check that. So prediction, Thomas planned an investigation. He made a prediction. So what is he predicting now? He's predicting that if I pass cathode ray between electrically charged pieces of metal, the rays will change direction. The rays will bend towards the positively charged metal. And I saw a GIF, very good, related to this.
And also, the next lesson is also talking about the same lesson as this lesson and another experiment, like they are talking about each other.
Look what is happening. He brought a metal piece, a positive charge metal piece. And now look, the electrons are bending.
Yes, the Mr. Shadow.
Showed you this GIF?
Yes, and also a video about it.
Oh, good.
It's meant to to be made in our science lab, but there was no the thing that we needed.
Okay, no problem. So carrying out the investigation and analyzing the evidence. So he carried out investigation. He made observation. The rays bent towards the positively charged metal. Okay, so these rays are going away from the metal or they are coming towards the metal? No answer. Sleeping. Are the rays
going away, Mr.
Going away from the metal piece when he's bringing on, or they are coming towards?
Away, Mr.
Away. So what is the charge of this metal piece? Positive or negative?
It depends. What
depends? The solution is all the observation. You can already observe it. If something is going away from the metal. Huh?
What is the yellow thing? Is it positive or negative?
Cathode ray, negative.
Oh, negative. So it's positive. So it's negative. Both of them
this
negative.
Cathode, yes, this cathode is also negative. That's why they are repelling each other. But if this cathode, if this electrode was positive, what will happen? They will come towards. They will come down. Okay. So look, the thing that I told you is written here, this thing. In that experiment that scientist did, Thomson did, when he brought the electrode, what happened? The line bent towards it. So meaning what? The line contained negative charge and that electrode contained positive charge. That's why they were attracting the cathode rays. Okay. So now what did we analyze? What did we understand? What are our conclusions? The conclusion is cathode rays are negatively charged. Khalas, this is our final answer. Yes?
Yes. And the other one is positively charged.
Thomson
atom.
asked more questions. He did some more thinking. He did some different investigation and collected more evidence. He closed the cathode of particles. Yes. Now, see, everything goes in development. It's not like one night you discover everything. No, it takes years and years. Like for example, in this experiment, are we finding out that what is electron, what is proton, what is neutron in this experiment? No. This is like a beginning stage of experiment. Yes. What did we find? We find that some rays are hitting the screen and the screen is glowing green. And what are our final conclusion? The conclusion is the thing that is coming out contains negative charge and they are being attracted towards the positive anode. Khalas, this is only conclusion. Yes?
Mr. I have a question.
Yes.
If the anode was like the same as the cathode, they would be neutral charged, right? Like for example, if the cathode was five electrons, and the anode was 5 too, and if they attract to each other, they'll cancel each other, and that will be neutral array
How they will be neutral?
because they would cancel each other.
See, these are two separate beings altogether. This is a separate being. This is a separate being. But when you are talking about atom, it's just single thing. So you can neutralize them together from outside because it's overall one thing. Neutral. Overall neutral. But this guy is overall what? Negative.
Negative.
This guy is overall what? Positive.
Positive.
That's why these guys are coming towards him.
Ah.
Okay.
Okay.
Mr. I want to ask a question.
Okay.
If there was
Maybe we'll take 3 hours today. Yes.
If there was like the high voltage supply is forming a positive electrode instead of negative electrode, and from the other side also there is positive electrode, nothing will happen, right?
That's your question. You are
Like,
telling me
if
here
there
you
was
have
positive
cathode
electrode
and
from the
here also you have cathode.
Yes.
I
No,
didn't try this.
not cathode, like anode, like nothing will happen. Like
And you have anode here as well as anode here.
yes.
No, nothing would happen. It will not
I think
touch.
it will be a draw match. I don't know about this. This is too much chemistry for me.
I think it will flow. I would think
it will be a draw match. You will decide by the penalty kick. This will be a draw match. So, a new model of the atom. Okay. So, what he did, he found out that the ray that was coming, they are made up of particles here. He said that what? These particles have some special properties. Okay. And they have very tiny mass. They have very small mass. They all have the same electrical charge. By 1897, Thomson had discovered the first subatomic particle, the electron. Okay. So Thomson is regarded as the discoverer. Let me check.
Of electron. And there is also Rutherford who discovered proton, and Marie Curie who discovered the nucleus. Or no, it's the same. No,
Discovery of electron, yes. Joseph John Thomson, yes. J.J. Thomson. Okay.
Wait. Mr. Thompson, what did he discover?
Yes.
Electron.
I will write it here. I will write it here.
And in the next lesson, Mister, we will learn who discovered protons. That is Rutherford.
So we need to know Thomson and Rutherford.
Electron.
And I think Marie Curie who discovered the neutron.
No.
Yeah, discovered by
Marie.
Joseph John. Thomson. In my school, we learned, I think, only J.J. Thomson. Just the initials.
Yes,
J.J. Thomson.
Mr. The one who discovered the neutron is James.
James Chadwick.
We still I didn't even go there yet.
In the next lesson we will.
So a new model of the atom. Now Thomson knew the electrons are negatively charged. He also knew that atoms have no overall electrical charge. Yes. atoms are considered overall neutral. Overall. Yes, when you look at outside picture, overall is neutral, any atom. Now in
What?
1904, what is the
Did you say
overall
what, sir?
charge of an atom?
Neutral.
Oh, neutral.
Not neutral, neutral.
Neutral.
You are making neutron and neutral in a single word. Neutral. What is neutral? Neutral. Okay.
Neutral.
So in 1904, Thomson used this as evidence to suggest numeral atom. An atom is positively charged sphere. He said there are negative electrons embedded in the sphere. So he's giving this type of example that the electrons are spread out like this.
Like the chocolate chip is the electrons.
Yes. So these guys are referred as electrons.
And the atom is the pudding.
There are negative electrons embedded in the sphere. The model explained the observation in cathode experiment. Some people said that Thomson model reminded them of a plum pudding. The plum pudding is an analogy of Thomson's model. And what are the points?
Electrons are negatively charged, but the
Electrons are negatively charged, but the plums in the pudding have no charge. Okay.
like how?
So plum is type of a fruit. And this pudding?
Pudding
I thought it
is
was a
like a
cake.
cake, mister.
Yes, pudding is like a cake, but plum is a fruit. And you cut the pieces of fruit and make a cake of it.
Yes, like the orange or the.
Like you have already, like you can make like strawberry cake or something like that, cherry cake.
Yeah,
like
orange
that.
cake.
Okay. So, but I need to check it one more time. What he said. He said atom is a positively charged sphere. And he is saying that overall, it is positive. Overall.
Maybe
He said there are negative electrons embedded in the, look what he's saying. An atom is positively charged sphere. Atom. What is atom? The full structure is
yes.
positively charged sphere. He said there are negative electrons embedded in the sphere. Embedded means put here. Then what?
The story continues.
Story continues. The story continues, huh? For more, yes. For more information, stay connected to our channel for the next video, huh?
Yes, yes, mister. They are saying that because in 7.3 we will learn more about this.
In Thomson model, the atom is a positively charged sphere, but the pudding has no charge.
What? Like mister, the electrons is positive, but the atom is like I didn't understand the analogy of plum pudding.
That's what I'm trying to understand. He's saying that overall it's positive.
Like overall, the atom is positive.
Look, an atom is a positively charged sphere. There are negative electrons embedded in the sphere. And how? We have to understand using these 2 points. Electrons are negatively charged. We all know that. But the plums in the pudding have no charge. Okay.
Maybe the plum. No, the plum. Maybe the plum is like making the atom or the blood.
Here, no charge.
Like inside the
these are the pieces. These are the pieces of the fruit. Yes, these are the pieces of the plum fruit.
Yes.
Okay. Electrons are negatively charged, but the plums in the pudding have no charge. In Thomson model, the atom is positively charged, but the pudding has no charge. So,
mister, if you will take like 3 hours today, you can add like 10 real of the.
No, I have other students also. I have given time. Okay, let's do the next question. Maybe we will understand something better.
The next lesson will talk about the proton and another experiment.
Finding the nucleus. Oh, okay. So what are the questions here? Thomson suggested that cathode rays are electrically charged. Describe the evidence that supports this prediction, because they were moving towards the positive anode.
Yes.
Okay, so if something is moving towards positive, we can say that that thing itself is negative. That's why it's moving towards positive thing. That's the first answer. Question number 2. List the steps that Thomson took in his investigation that led to the development of his model.
An atom is a positively charged sphere.
Oh, you're reading from here, huh?
Wait, Mr. How can we answer this question?
List the step that Thomson took in his investigation that led to the development of his model. And what is the next question? The plum pudding analogy has to explain Thomson's model. Describe two strengths and two weaknesses of the plum pudding analogy. Okay. These two questions, I think. The third question, I think, I need to check what are the problems in this analogy and what are the good points in this analogy, because I myself did not understand it fully, that he's saying overall it is positive, but the plum has no charge. So I need to look into it. Okay. I'll not waste more time now because I have no information about this thing. Okay.
Okay.
So
Mr. What was
finding
the
the
answer
nucleus.
question? I was lagging.
Lagging, you missed. I'm saying I need to
Hello?
look into. I'm saying, yes, you can hear me
Yes.
or not.
Yes,
So I'm saying I need to look
I
into
can hear
that.
you now.
I will check it later. These two things. Not these two things. I mean the last
Even
one.
question 2?
The question 2 lists
The
the
number
steps
2.
that Thomson took in his investigation that led to the development of his model. So we have to show his investigation. So these are the investigations. And Thomas carried out his investigation. He made observation. The rays bent towards the positively charged metal. His prediction was correct. But still, Yani, do you guys have the answer key for this one?
No.
Yeah, no, I don't.
Or the teacher
can
made you write some answers for these two?
No.
Like he
No.
don't care for the
No.
question.
Yeah.
Okay, so we can check it later. Okay, we can check it later.
Okay.
So I'll quickly do this one and then we'll take a small break. Okay, I'm very hungry now. Finding the nucleus, not because of looking at this, but I'm hungry. Okay, so finding the nucleus, testing the plum model. But this is looking good, Yani. I need to purchase tonight something like this. I have this in my market. There is a fresh fruit cake. It looks like this. They put kaju and they put some dry fruits, like 2 or 3 dry fruits, and they have a cake like this.
Mister,
Very,
there is
very-
also like the cake, the fruit cake, like orange or lemon. You can do it. It's also good.
So Thomson told other scientists about his plum pudding model. How did he tell? What's that?
What is no,
No.
uh,
I read the
حمام
thing that we took in chapter 6.
no, sir.
And the thing that we took in chapter 6, I forgot it.
Thomson told other scientists about his plum pudding model. He posted it on WhatsApp or what? On Facebook?
No. Mister, we took it in chapter 6. I forgot the name of it.
What?
In chapter 6.
What are you talking about?
No, we took it. We took it the same thing, like where you can post your stuff before. We took it in chapter 6. Last chapter.
Yeah, you.
What?
I don't know what you are talking. I don't know what
No,
you are talking about.
No, like Thompson, like he released what he did, his experiments in a place that we took it in chapter 6. Yeah. In
Yeah, I'll
6.2,
move
I
on.
believe.
I'll move on. We are not going anywhere. I'll move on. For now, testing the plum pudding model. Okay. There was good evidence for negatively charged, but what about their arrangement in a positively charged sphere? What was the evidence for this? So we are further breaking it down. So testing the plum pudding model. Now, Ernest Rutherford lived in New Zealand. You guys know where is New Zealand?
Yes, in Oceania,
Below Australia.
below Australia.
Australia.
Below Australia, not Australia. Below Australia. Okay. And New Zealand has a very good cricket team also. So Ernest Rutherford lived in New Zealand until he was 23. In 1895, he moved to England to study under Thomson. Oh, so he was like a student of Thomson, this guy. Okay. This guy was a student. So Rutherford planned an investigation to test Thomson's plum pudding model. He made a prediction. We will fire positively charged particle at a piece of gold foil if the plum pudding model is correct. Most of the positive particle will go straight through the foil. A few will pass close to negative electrons. Those positive particles will change directions slightly. Ooh, I need to study it one more time. This is very tricky and very important thing for exam. Prediction. We will fire positive charge at a piece. Okay, now we are throwing positive guys. To what? To the gold foil. Yes. Positive foils. Not positive foils. Positive charge. We are throwing at the gold foil. What is gold foil? Very thin paper-like structure of gold. Like you have silver foil on the sweets, you know? Silver foil. In India, we have.
What, mister?
You guys can hear me or no? You have disturbance.
No, mister, we can.
So
You know what
can't
is
plug
gold
it.
foil, right? You put it on the expensive sweets. Gold
Yes.
foil.
Yeah.
Or you don't know?
Yes.
Yeah, yeah.
Waraka. Yes, waraka for the Habiya, maybe.
Yeah.
I don't know. I don't know if that is the proper. Meaning.
Mister, like there
Mister,
are.
صدير ذهبي صدير ذهبي.
It's like a 30 real, mister, in the supermarket, but I don't know why they only put it on the expensive foods.
Okay, so from this machine is what? This is positively charged and it's throwing the positive particles to what? To the gold foil.
Yes.
And what happens?
There are holes.
First they are predicting something. They are predicting what? Yani guessing something. Prediction. Prediction. We will fire positively charged particles at a piece of gold foil. Okay, then what will happen? If the plum pudding model is correct, most of the positive particles will go straight through the foil. Okay. A few will pass close to negative electrons. Those positive particles will change direction slightly. Okay. Let me read further, then I'll explain to you the whole story. Yes, I'm understanding now. So the scientists fired positive particles at the goal. The results were amazing. Around 1 in every 10,000 particle bounced backwards off the foil. Rutherford wrote, "It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fire an artillery shell or weapon at a piece of tissue paper and it came back and hit you." Wow, he was so happy that day. The scientists discussed their observation. Rutherford's prediction was wrong. He had based his prediction on Thomson's plum pudding model. This, said Rutherford, means the plum pudding model must be wrong. Oh. Things are getting intense. Rutherford thought about the problem. Could he come up with a better model to explain the evidence? Okay, so that means that model was rejected. Which model? This yummy stuff. Okay. This plum model was, what did he say? He said that overall it's positive.
Yes.
Overall, the atom is positive, correct?
Yeah.
Okay. Now, to prove this point, what he's saying? He's saying that in this gold, also there will be so many atoms.
Yes.
Yes, because it is a metal. And these atoms are what charge?
Neutral.
Positive charge. Positive charge. According to the plum pudding theory, not according to today's science. According to the old thinking. Okay. So these guys are positive.
Okay.
So what he observed that these positive guys are hitting the positive stuff. So what happened? 1 out of 10,000 positive particle bounced back. Yani which particle? That blue particle. that was coming, and it hit the black particle, and then it's going back. The blue particle is going back. Did you understand why? Because positive guy will repel the positive stuff.
Okay, now I okay,
Understand?
like every time, Mister, it hits the atom inside the gold foil, it will be repelled back into the holes.
I'll bring one GIF.
Like, Mister, what is
it
the
make
function of
things-
the holes in this? Like, why there are holes?
Where are holes?
The green holes.
These are not holes.
What are they?
These are light, green light.
Okay. Like it will the charged, like the positively charged atom will go to the screen and it will light up, right?
No, I'm bringing one good, very good GIF now. You guys will understand
So, Mr. In the
much better.
Mr.
Lala, wait.
Mr.
I'm not answering anything. Wait. First, let me hear. Remember your question, okay? I'll come back to you in a moment.
Okay.
Wait. Now look at this beautiful thing. Look at the beautiful animation.
Right.
What is happening? The positive charges are being shot from here. Okay? Positive particles. Now what is happening? Positive particles are coming and hitting the gold foil here. Now what is happening? If you zoom in here, you will have positive particles. So when positive, I will use different color. For example, the gold foil is yellow color, so I will use yellow color. Okay, so you have these positive structures, yes?
Yes.
Now, when this gun is hitting positive guys, and when this guy is nearby positive, it will not go straight, and it will go deflected. Why? Because of repulsion.
Yes.
Did you understand? Yani when a positive guy is coming and going through a crowd of positive guys, what will happen? It will change the
It's go
direction
away.
slightly. So sometime you will see the light here. Sometime you will see light here. Yani randomly you will see light here. Sometime you will see light here. That's the experiment. Did you understand the experiment?
Yes.
Now we will study
Yes.
more about this. But is everyone understanding what happened in the experiment so far? Or
Yes.
no? Badr,
I did.
Adnan,
explain.
he opened his mic.
Yes, mister. Say yes, mister. I will mute you. Totally. But he's already muted, Yani. That will not do a big damage. Yes, Badr, you're not
So he's-
responding anything.
Mr.
I'm
he's
asking you
unmuted.
something.
Maybe his mic is not working.
Yes,
He's
Mister.
unmuted.
La, everything is working. When he was speaking, then its mic was not working. Yani. It was working. Tell me quickly. I need to finish. I need to go. After half an hour, I'll finish. I'll not take a break now. I need to leave. No, not responding. Khalas, be silent. So, okay, let me erase all the stuff that I drew here. So you understand something. Now, see, we cannot understand everything so far, but you have to understand whatever we have studied. Now you cannot ask me, Mr. Why there are this, why there are this, why they no. Just understand step by step that the positive particles that were being fired here, they deflected so much here, and very rare pieces, yani in 10,000 hits, only one particle bounced totally back. So by seeing this, he was so happy, and he was so surprised. He was so happy.
Yes.
Who? Rutherford. Look, it's written here.
Yeah,
This.
Rutherford.
Mr.
But
Why
Mr.
was he happy?
Who is Geiger and Marsden?
Geiger and Marsden used this apparatus to test the plum pudding model in 1909.
Like they are assistants to Rutherford.
Rutherford did not work alone. Look. Rutherford did not work alone. He collaborated with Hans
Like
Geiger
they are
and Ernest
assistant.
Marsden.
Yeah, yes.
They set up the apparatus below.
Like they are
Okay.
assistants.
Yeah, it's possible. Yes, it's possible they are assistant, or maybe these guys are good in like arrangements. Like But
Yeah.
this was like the controlling guy. Maybe he was giving instructions, and these guys were like good in apparatus, setting the apparatus and like setting everything. Because you cannot be good in everything.
Yes.
Yes. Now, after this experiment, they are discussing what happened. And they found out what?
What?
The other scientists start telling Rutherford that you are wrong. Okay. Rutherford's prediction was
Wrong.
Where is the prediction? It's given here. Here.
Like everything he made was wrong.
Not everything.
Because like he's saying that
Look,
The-
look. Let me quickly drive the car. You are driving the car now. The car is going to have an accident. Let me drive the car now. Let me be the driver. Okay. Rutherford prediction was wrong. He had based his prediction on Thomson's plum pudding model. This means the plum pudding model was also wrong. Yani Rutherford is saying, see, Ana mish masool, and I'm not responsible for this. I based my assumption on the plum pudding model. So if you are telling me I am wrong, halas, this is also wrong because I took my ideas from this model. Yes. So it
okay.
was proven that plum pudding model is wrong. Why? Because the Rutherford prediction was wrong. Okay, khalas, everything is wrong. Then what is correct? Now let's look at the recent developments. But the recent developments are still so old.
يعني
100
مثلا
years.
he
100
قصف
years
في
old.
الجبل.
What is qasaf?
يعني he bumped their foreheads.
Who?
Rutherford to the plum pudding model discovered. Like in Arabic, Mr. we say he قصف
1
في
minute,
الجبل.
1 minute. रोटी बनाई वो भी ठीक है 2 मिला हाँ ठीक है yes you what you are saying
Like Mr. In Arabic we say he قصف جبهته or like when someone said something then the other one will reply on him with better thing. Like, okay, Mr.
It
Ignore.
means roasted him. Roasted him.
Yeah, roasted him. Yes.
I thought he did suicide. According to your
No,
explanation,
what
I was
suicide?
thinking
No,
he did. He bombed his head.
No.
You cannot
Roasted
literally
him.
translate Arabic to English and then think that everyone
No.
will understand what you mean.
Mr. Qasif جبهة mean roast.
Yeah, roasted.
Like I roasted you.
Like when he said
What
that
about if
even
we
you
roast
in
this
front-
plum pudding? Wow, the smell will be so good. Okay. So by 1911, okay, let me check. Let me take the attendance. You
Okay.
guys are speaking already. Ibrahim and Adnan and Badr, they're not speaking.
Salam
Are they
alaikum.
present? Alaikum assalam. Adnan is there, Ibrahim is there. What about Badr? Yes, mister.
Yes,
Adnan, go and check where. He's there. He's here. See?
He said yes, Mr.
Yes, and then he instantly muted his mic in 0.1 reaction time seconds.
Mr. You
Instantly
heard
switched
any
off.
commentary?
yes.
What?
You heard
Yes.
anything now said like ساعة اثنين?
Oh.
There is a narrator in my laptop that says every
Okay.
Did not
every
say.
now.
Did not say.
Okay. Can I continue?
Yes,
Let me mute
yes.
these two guys.
No.
Yes.
What? Yes. You are the first guy. I'll mute. Yes. Disable mic and disable mic.
Fine.
Yes, I need to run quickly. Okay. So a new model for the atom. Now, see, this is how humans learn. They make an assumption, they make a hypothesis, then they check it. If it is correct, and if you prove it to be correct, khalas, it will be accepted. But if your discovery or was wrong, then someone has to prove it wrong. And when he proves it wrong, then khalas, then his theory will be accepted and your theory will be rejected. This is how we find new things. So similarly, after experimenting only we can find. We cannot just sit in our room in our AC and then we can make decisions. This is this is it, this is wrong, this is right. No, you have to do some like actual work. So the plum pudding model was rejected and the Rutherford prediction was rejected. It's not that this experiment is rejected. No, the experiment is good. The experiment is working fine. But the prediction that he made, they were rejected. That this is happening because of this is happening. This prediction was rejected, but the experiment was legit good. The experiment was not fake. Okay. So atoms have a central, okay, Rutherford had developed new model. Okay, now he's giving new ideas. What? He's saying atoms have a central nucleus. Okay. Most of the mass of an atom is in its nucleus. Very good. Because nucleus contains very heavy material like proton and neutron, which are heavy, but electron is outside surrounding, so it's lightweight. Yes. Okay. The nucleus is positively charged. Okay. A nucleus is surrounded by empty space in which electrons move. Okay. So this is how we have. Yes. We have protons and neutrons outside, inside, at this structure, which is the nucleus, and electrons revolving outside here. These things were not included in the plum pudding model. That model was very different. But now this model is very similar to the current day model. And what else? Rutherford new model explains surprising observation. What are the surprising observation? This the teacher can ask you. What were the surprising observation in the Rutherford new model? There are two answers. What is the first answer? The
Yes.
positive particle that
Question.
bounced back hit a nucleus. Okay, it hit a nucleus.
Yes.
And what else? The positive particles that went straight through the foil had passed through the empty space. Oh, now when there is obstruction in your field, yani when you have someone standing in between you, how can the positive particles go straight through it even though there is no hole in the gold foil? How? How can this go? Why? Because in an atom, you have a lot of empty space. A lot of empty space. Yani you have nucleus here. And you have electrons where? Here you have electrons. Okay. But this space is empty. This is all empty space. Yes. There is nothing here. That's why the positive particles that were coming out of there, the positive particles, they are going what? Alas, they are going in a straight direction. There is nothing to obstruct. Yes. Now all the mics are working. So this is why the positive particles went straight. Yes, you can see.
Yes.
Or not. That's why they are coming straight. Why they are coming straight? Explain. Why they did not get deviated from their straight path. Ibrahim, tell me.
Because they get reflected back.
What?
Because they
Listen
are
to
different.
the question.
Can I-
Listen to
can
the
I-
question. In this GIF that I'm showing you, what is this?
Gold
Good.
foil.
Gold foil. Does it have holes or it is without holes?
Well, it does have holes. So
No. This is a regular gold foil like this. Are these gold foils having holes?
No.
no.
Looks like anything.
So why are the positive particles that we are firing from here? They are going straight away and hitting this area. Why, Ibrahim? Tell
Can
me.
I answer, Mr.?
No. Wait for your turn. Ibrahim, tell me. You know or you don't?
I don't.
Okay. Badr, don't answer. Adnan, do you know why?
No.
Okay, Muhammad Ali.
Yes, mister.
Khalas, ma
And
salam.
how do I know? How do I know? Mister, I know how.
Tell me.
So, mister, like it when it goes through the gold, it goes right, left, anywhere. But only 1 in 1,000, it goes back.
That wasn't my question, and even in that your answer, you are giving me wrong number. One in 10,000 return back. It returned back.
Yeah.
Yani one particle.
As a-
I'm not asking about the returning particle. I'm asking you the straight particle that went straight away. Why did it came here? Is this
No,
gold
this I don't
foil
know.
having so
I
many
don't
holes?
understand it.
No. So I think only Muhammad Amir knows the answer. Yes, Muhammad
I
Amir.
think, Mister, like the only one that goes through is differently charged from the gold foil.
No, so no one knows the answer. The answer is if you zoom in to this gold foil, zoom in, zoom in, zoom in, zoom in too much in the gold foil, what will see?
For
You will see there is
well,
too much empty space in the atom.
Yeah.
Yani, if you will see, what? I will show you something. Is this
like
the
there,
structure of an atom? Yani,
yeah,
for
like
example, this is,
but
I'll show you something. For example, this is the first shell. And after that, for example,
second shell.
these
third
are the second shell. Now, if I take a no, first of all, I will reduce it. Okay. And I may copy paste, bring it here. Then I make copy, paste, 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 paste. Wow. Music is coming from my experiment. Tan, 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 tan. What do you guys see now? There are so many gold atoms, yes?
Yes.
Yes.
But most of the space is empty. Yani
Yes.
if I hit something here. Wait, let me draw a straight line. Look, okay, in this straight line. Oh, sorry, I mean this straight line. This straight line will go straight. Is there any obstruction?
No.
There is this obstruction here. Here.
Oh.
But for example, if this was not there, so my positive particle will keep on moving in the straight line. Do you understand why? Because
Mister,
most of the space in the atom is what?
empty.
This.
Empty. Are you guys understanding the reason now?
Yes, but Mister, if there was any obstructive like in the straight line of this atom, it will go like mostly it will go through an electron, so it will be more
It will go
attractive.
through deviated. It like for example, this is my positive gun. Okay, red color
Okay.
is my positive gun. I'm moving, moving, moving. No obstruction, no obstruction. Now I hit a negative guy. Maybe I will
It
get
will be attracted.
attracted. So
Yes.
instead of this path, wait. Now here, what I will do, I will stop here, and then my light will bend like this. You know why it bended? Because I met a negative guy, and negative guy tried to attract me. That's the thing. That's why I got deviated. But let's take another scenario. This scenario. Khalas, there is no obstruction. I will keep on moving in the straight direction. Are you guys understanding or no? I'm just talking to myself.
No, I am understanding.
Yes.
Did you understand why are the lights hitting here even though there is no visible hole in the gold foil? Are you guys understanding, Ibrahim,
Yes.
or still unclear?
Yes.
Ibrahim?
It's a little unclear.
Little too unclear. Okay. See, I already showed you the microscopic view of the gold. Yani, if you look at from here, this is your gold foil. Where this is your gold foil. Okay, I'm giving a very big version. This is your gold foil, correct, Ibrahim?
Yeah.
If you zoom gold foil under microscope, you will see something like this.
Yes.
Okay, without the orbits, I mean. Okay, you will not see the orbits.
Yeah.
Then you will just see the circles. Okay, you guys can understand. Orbits are created just so you can understand what is electron. But orbits are like imaginary lines.
Yeah, you don't have to remove all the orbits. I will still understand.
You will understand now. Now imagine I throw a positive charge in a straight laser form of line. I'm throwing this positive line. It will go straight. Why?
Yeah.
Because there is no obstruction in between. That's why in this gold microscopic structure, what will happen? These balls that are coming here, they are passing through with the gold foil. Why? Because these particles that are coming, they are not big particles like marbles or like the M&M. No, it's very, very microscopic particle. You can't even see with your own eyes. So these guys can easily pass through the gold foil. Why? Because they are so small and there is a lot of empty space in an atom.
Mister,
That's
is
why.
that what I said though? Like when you
What?
asked me,
What?
I said that when you asked me if it has like holes in the gold foil, I said
See.
yes, technically, because there's
See.
like really small holes in between.
Okay, or at a microscopic level, you can say, but like on a visible level, like our normal eye level, we cannot say there are holes. Can we say?
That's
No.
true.
Okay. Like
Yep.
here, like here. From our normal eye, can we see any hole? No.
No.
But when we go to the microscopic level, there are too much holes and empty spaces. That's why you can see the light in different directions. But does that mean light will only travel in the straight line and these positive particles will only move straight? No, sometimes they will hit some obstruction, so they will hit here. Sometimes they hit, they will go here. And in rarest of the rare situation, what will happen? It will hit the nucleus and bounce
And
back
go.
from the same origin. Now, nucleus is what charge? What is the charge of nucleus?
Neutral.
Positive.
No, overall it's positive. Why? Because neutron is negative. Look here. Students get confused in this answer.
Wait,
What is
neutrons
the
are
charge? What is the charge of neutron?
no charge.
No charge. But what is the charge of nucleus? What is the charge of nucleus? Positive.
Positive.
Because it contains neutrals as well as positive. So what is the if
Wait,
a positive guy is coming towards nucleus, what will happen? It will repel back to the same path.
Yeah.
It will bounce back. Okay. That's why Rutherford was so happy after it got refracted back.
Wait,
one in 10,000.
So the neutrons don't cancel out the protons?
Why they will cancel out? Neutrons are not negative. How will they cancel out? You need to be negative to cancel the positive. But if you don't have any charge, how will you make it negative? So overall, nucleus is what?
Positive.
Yes. So in that fill in the blank, I am expecting this question will come. That the teacher can ask you, nucleus, the charge of nucleus is, then you will be given three options: positive, negative, neutral. And some student will think, oh, the answer is neutral. They will write neutral. No, the nucleus is positive overall. Why? Because of the protons that are sitting next to them. Did you guys understand?
Yes, but the atom is neutral.
Atom overall atom is neutral. But if I ask you just the nucleus,
no, the nucleus it will be positive because
positive.
there is proton in it. Because
Yes.
proton
Because of protons. Yes, because of protons. Yani aslan because of protons.
Yeah, +1 +0 equal 1.
Inshallah, I need to check it on my calculator also to verify. Okay.
Mister, I think
the positive particles that went straight through the foil had passed through the empty spaces between the nuclei. Okay. The plural of nucleus is nuclei. Okay. This is the plural.
Bronchi,
Plural.
bronchus.
Yes.
Bronchi,
Yes.
bronchus.
Bronchi, and radius, radii. Not mucus and muci. I have never heard mucus and muci. Is it so?
No, I said bronchus. I said bronchus. And
No,
bronchi.
I'm talking to Muhammad Amir.
No, I said, Mister, nucleus is if there was no nuclei.
Nucleuses. Not nucleusats. Not nucleusats.
Nucleus.
Huh? Not nucleusats for you.
Do you understand?
Okay. Now inside nucleus, what is happening inside the nucleus? Scientists wonder about the nucleus. Was it made of smaller particles? Rutherford collected evidence. He fired positive particle into the air. Oh, he's firing. He's firing positive particles into the air. Tiny. The Rutherford realized that the particle came from the nuclei of nitrogen atom. The tiny. My energy
Like
is gone.
Mr.
Now I'm so hungry. And maybe 15 minutes more, and then I can end the call.
But Mr. still there is this chapter.
Scientist James Chadwick investigated this question in 19. Previously, I don't know why you guys didn't discuss this with me. There were so many Fridays and Saturdays you did not take any class, and now one day before you want so much detail.
Mr.
It's not possible.
We can take tomorrow if you want.
Tomorrow, why tomorrow? Tomorrow is not your exam?
No, tomorrow is biology.
No,
So
biology.
tomorrow we can take chemistry class.
No, but then the parents will think, and why is this guy giving 2 classes for the same subject? I don't want that.
No problem. Mister. You can
No,
say
no.
in group.
No.
Or you can make like you can make it like free like today at night or tomorrow.
Ooh. By 1932, yeah. I will check. Let me see how much we can finish in 15 minutes, and then we will think.
Okay.
By 1932, okay, so this all stuff I will tell you to read. I'm just telling you the 2 conclusions. The model of an atom now included. So what are the improvements by James Chadwick? What were the improvements? The positive protons and neutron neutrons in the nucleus. This is good.
Yeah.
Yani they are telling us that the protons are positive and they are telling us the neutrons are negative, which is good. Okay. And what is the second thing they are proposing? They are proposing that negative electrons orbiting around the nucleus, which is good. Yes.
Yes. So this is like the model till today.
Yes. So this is the model you use today. Several scientists build on each other's work to develop the model. Okay. So if you are asked who discovered neutron, I mean,
James
let me
Chadwick.
check. Let me write it. Yes.
Yeah, James Chadwick for neutron and proton, Rutherford and Thomson for electron. And there are 4 other scientists.
So this guy, okay, I'm writing here. Discovered what?
Discovered the
Nutella.
Neutron.
Not Nutella. Who hates Nutella? Or who loves Nutella? The chocolate, the peanut butter. Do you guys love peanut butter or no, or not very much?
No.
I like it. I like it.
I don't love
How
it.
do you consume it? How do you consume directly from the spoon?
No, on a sandwich, like on a toast or
Sandwich, Mr.
Like on a bread, on a bread piece, on a bread piece.
yes.
Yeah, on a bread with cheese. I put cheese with butter.
Everywhere you
with
put
peanut
cheese.
butter.
Like
Do you drink water normally or do you put cheese in the water?
jam or
No,
jelly
Mr. No,
stuff.
it's so tasty, Mr. Put like the
Tasty.
بقرة cheese, the slices.
رضاحك.
The bakara.
Yeah, that one. Yeah, the
Uh-huh.
triangle slices, the triangle cheese slices with it.
Oh,
it's so yummy.
the triangle
Yeah.
cheeses I cannot forget. I cannot forget. Cheese
It's so
triangles. Oh, they were lifesaver for me.
Mr. Like also
I'll show you something quickly.
Peanut butter is also like good with the jelly or jam.
No, I don't like it. I like it with cheese. With cheese. Yeah, this one.
This one is lifesaver. I like to eat it directly and it's so yummy, so tasty. I just open the aluminum foil and I eat it directly. It's so salty. Very good.
I do like that. Yeah.
This was like I think 18 riyal, something like that, or 16 riyal, something like that. The whole packet.
It's for 10 riyal. 10 riyal my supermarket.
Oh.
Mister, my supermarket is like 7, 8.
Oh.
There is also Mr. Smaller packets like.
No.
I hear someone is opening some cheese packet or what?
عدنان البدل.
Badar. Oh, kachar. Okay. So this guy discovered what? Neutrons. So we have studied neutrons were discovered by James Chadwick, and
And Thomas discovered
electron.
protons.
Yes, electron. What is
Electron by Thomas.
J.J. Thomson? And now what is
What?
remaining? Proton. What
Proton
was?
by Thomas. Thompson.
No, Rutherford.
No, Rutherford.
Proton.
Yeah,
This guy.
So I thought electron was by Thompson.
yeah.
Then
That's what I
is-
wrote here. Look, what Muhammad Ali, where are you?
Oh.
On which lesson are you? Biology.
Oh, it's Joseph John Thompson. Mister, can
Can
we
I
say
say?
Thompson only?
Yusuf Jihad.
Mister,
You
can we
can-
say in
you-
the exam Thompson only?
It's difficult. Just say J.J. Thomson. J.J. Thomson, that's all.
JJ.
Okay.
Thompson.
J.J. Thomson, okay. Now Rutherford.
Um,
Where is the name? Ernest Rutherford. Okay.
Ernest
But Mr. like Marie Curie
Guy
is like
discovered.
Rutherford.
Mr.
Proton.
Marie Curie is like
Proton.
useless, right?
What?
Marie Curie, the scientist Marie Curie, is useless because she didn't do anything in the experiment.
He didn't do anything. Then why her photo is there
I don't
in the
know.
books? You don't know. You need to check.
Like there is nothing written in the lesson about.
Because
Marie Curie and Ernest Rutherford organized a conference in 1913 for scientists to discuss models for atom. And as far as I remember, she played a big role in discovering radium. Do you know what is radium?
Radium is like the.
In the watches, do you know what is radium? It glows green color. When you
Yes,
put
yes.
it,
For
when you
the
take your watches in a dark room, they light up.
yes,
You know
yes,
or not?
yes, yes.
What about other students?
Like it happens
I
from
know.
the electrons and protons from the because there is a fluorescent screen in it, so it will light up green.
Like this, like this.
Ah, yes.
Okay. So, who discovered radium? Radium. Wait, let me check. Discovered by Marie Curie and Pierre Curie. Look, husband, wife. Yes, Muhammad Amir. They didn't do anything, huh? Useless.
I am more useful than him.
You are more useful, huh? I hear beluga sound at the background. Is it beluga or Discord sound?
No.
No, Baluga, Mister Baluga.
Look,
Marie Curie and Pierre Curie. They are cousins, Mr. Not. Are they?
they are
They
cousins.
Yeah, because they are the same like family name.
No, after marriage also the husband can take the name of the husband.
Oh.
It happens in many places. Wait.
Curry.
Yes, they are husband and wife. It's given. You can check it. Anyways,
Yes, radium was discovered by me.
so and radium is very, very harmful, very dangerous thing. And she used to keep it under her pillow before sleeping. Yani.
Wow.
She don't know about that it is so dangerous. And then she died from the radiation of radium. You know this?
Like it's like mercury, Mister. Radium is like
Not
mercury.
mercury. See, mercury will not give you radiation.
No.
What is radiation? It passes through materials.
Yes, but no, I'm asking about the dangerous, like the danger of each element. Like radium is also dangerous as
Yes.
mercury.
Look here. Look, Mafish. Look at the reason for her death. On July, this. What was the reason? Several years of exposure to radiation through her work. She died because of radiation. It was so dangerous. And she used to keep a radium under pillow. Okay, anyways.
People put their teeth under the pillow, she put radium.
To get the FIFA 23 coins the next morning, maybe. Uh-huh.
Yes.
Tooth fairy will come, huh?
Yes. FIFA point.
FIFA point, huh? And still, when you play, you have 1000 ping. Ma salama. Okay.
No,
Average
9999.
Arabic.
9999, 10,000. Oh, Satyendra Bose was born in Kolkata, India in 1894. Now, finally, Indian has entered the chat. Okay, inside. I thought this is written in India, but this is written inside. Sorry, Manish. I see India everywhere. Inside subatomic particles. Now, in 1932, scientists knew that most of the mass of an atom is in nucleus. Yes, the nucleus is the heavy stuff. Why? Because it has all the heavy things, neutron and proton. And electron is almost nothing compared to the mass of nucleus, because nucleus is so heavy. It contains too heavy stuff.
Yes.
And electrons is how many times lightweight than neutron? How many times?
2000.
Ibrahim.
Oh.
Yes, mister.
Yes.
I asked them for the answer and they give me their attendance.
Mister, are you asking like the relative mass of electron?
Aywa?
1 out of 2000.
Oh, quickly browsed, eh?
Huh?
Very smart guy. Very clever
Very
guy.
smart.
Now, collaborating to find answer. Now, scientists are collaborating like these days. Nonsense YouTubers are collaborating. Previously, there were senseless guys, like, I mean, senseful guys, not senseless guys. Like, they have some important research. They have some important findings. They will go to their houses. They will visit their places, or they will make a conference, and then they will discuss about very, very important matters and points and issues in science. Okay. Hello.
Yes,
Mohammad
yes.
Ali, you have problem in this?
Yeah, but
What's the problem? That why did they use
So-
WhatsApp? Is this your problem?
what? What?
Nothing. Tell me quickly, I'm leaving.
You'll go, mister?
Mister, like in the you're leaving, Mister?
Tell me quickly.
In this, like in the part of like the find answer, that the this part, the hypothesis.
What are you saying?
Mr. Khas, continue.
I think, mister, like this is the
It
least
was better
important.
if I kept them muted. These two guys.
I think, mister, this is the least important lesson in the exam.
This is the least important lesson inside subatomic particle. This one.
Yes.
What
and
are
then,
the questions? Explain why peer review. Oh,
Yeah.
they're asking about research thing. This is in
we-
my masters. This thing.
and
in my
also,
masters.
we took it before. You remember in chapter 6? In
Yeah, I
the
remember
Maybe.
that.
we
Now,
took
give two advantages of collaboration. Collaboration is very helpful. We get the ideas of other guys, and maybe if we are making a mistake in our steps, maybe we will get correction. Okay,
Yes.
and there are many advantages of collaboration. Yes, you know what is collaboration in YouTube world? You know what is collaboration in YouTube?
Yes, yes.
Yani there are masalan one YouTuber from maybe Morocco and one YouTuber from Algeria. They will go to their place, they will make videos, they will do collaborative videos, and then they will post the same video on both channels.
Yes.
And they will get millions of views both places. Yes, this is collaboration. This is
See, mister.
I cannot see now. La. Now, protons and nucleon numbers. Oh, this is one of the most important things in the history of chemistry.
Yes.
This periodic table in the history of chemistry. Okay. So in this one, you have the elements placed in a specific place, like hydrogen is here, helium is here. Then you have lithium, beryllium, boron, carbon, nitrogen, like this. What is happening at the background? Is someone constructing a building in your room?
Mister, I'm fighting the swarm of ants in my room, Mister.
Swarm of ants in your room. Why? Do you have a bunch of candies with you sitting next to you, or what? Why do you
Yeah.
have so much? Yeah. See, meow has entered the chat. Okay, but now till now we have not studied about this new word. Have we studied about this new word? We have studied nucleus. We have studied neutron. But what is nucleon? Nucleon is the number of proton and neutron
And the
combined.
neutron.
Yes.
Okay. Yani number of protons. For example, if I come back to my original beautiful drawing, what is the nucleon number here?
8.
8. Yes. The 8 was correct. What was the spelling? Make sure the spelling of was correct. So number of protons. I hope I'm teaching humans. Or my marketing is going to way beyond other humans, maybe aliens also. Number of he is hitting the ants with his slipper. I can feel the sound. He's hitting them with slippers. Ibrahim, what are you doing? Look what he's doing. His camera is open. Number of protons plus number of neutrons will give you what?
Nucleon.
Nucleon number, okay?
Nucleon.
Nucleon number.
And there is also the atomic number and proton number, mass number.
Mister, it's also called mass number.
Yes. Mass number you have to pay attention because this mass number you will be using in bigger grades. You will not use nucleon number in future, okay? So you have to pay attention on mass number. So I will write mass number in a big font and I will write nucleon number in a small font because that's less important for us now. Who is crying? A cat is crying or what?
Mister,
Crying
I'm
cat.
crying because of 2 hours studying chemistry.
Ibrahim forgot to mute his mic maybe. Huh? Cat is crying. That why did you kill my friend red ants? Okay. So now. Okay. Now I'll ask one last question and then we are going.
Oh.
Okay. I will show you one thing. Fluorine. 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 Which is
Mister, can you hear me?
yes.
Can you hear me well?
Yes, I can hear you very, very well.
MashaAllah, my headphone mic is.
Crisp.
No, Mister, I mean my camera mic, Mister.
Camera mic. Camera mic. Oh.
Yes, Allah, this is my camera mic.
Okay.
It's better. It's better.
Now I will show you one
Mr.
last
Monkey
thing.
Board. Mr. Also, like there was a important thing we had to study, but I think we can't now. That is the configuration.
Important thing that we have to study. Oh.
Like configuration, Mr. We didn't. Or it's not this, I think.
Now
Yeah,
guys,
it's not
pay
with us.
attention. I'm taking a snapshot I'm taking a screenshot of here. What do you see here? Now focus on fluorine. Is everybody with me? I'm going to show you one interesting thing.
Yes,
Yeah,
okay.
Mister, I know it's an electron configuration 10.2, Mister.
Yes.
Easy
Now.
peasy lemon squeezy.
Now, focus on this fluorine.
Okay.
Okay. So the number.
Mister, can you mute Hima?
Mr. Hima, what is happening? Yes, he muted his mic already. Okay. Now look. You have this fluorine. I took a screenshot and this is the zoomed in version. Okay. Now, if we focus on fluorine, what is happening? You see some numbers.
Yes.
Focus on this number and this number. Okay. Now, this number is 9. This number is 19. 18.9, 19. Now, look. The
Equal to-
number on the top is the atomic number.
Okay. And the second one is the mass number.
Mass number.
Yes.
And what is atomic number?
Atomic
Mass
number?
number you already know. I already
Yes.
told you. Mass number is what? Nucleus stuff.
Yes.
Nucleus stuff. Yes. What is
Yes.
atomic number? That is moving outside.
Number of
These
electrons, number of
guys.
electrons, sir.
These guys. Now count. Count. How many
Yes.
outside guys are there? Count.
One,
Here.
1, 2,
How
4,
many
5, 6,
electrons are there?
9,
9.
9. 1,
Yes.
2, 3,
3,
4,
4, 5, 6,
5, 6, 7, 8, and 9.
9.
No.
Okay. So 9 electrons. It's shown here. Very good. Now, can you tell me? Can you tell me what will come in this nucleus? How many proton and how many neutron? This is my question to you guys.
Mr.
Tell me
Kanan.
how many protons and how many neutrons.
Mr. I finished.
Mr.
But
I can
electrons
I
is
can say.
9. And the total sum should be 19. Yani this guy
Mr. Can I
plus
say?
this guy should be 19. Yes, tell me.
9.5.
Proton is 9 and the neutron is 10.
Yes.
Oh, guys, didn't I tell you in the starting that
Because-
atom is electrically overall neutral?
Yes.
So
neutral.
how many negative you have to
Uh,
make the same
nine.
positive.
Yeah.
Neutron
yes.
10.
Now, out of 19, 9 gone here. How much remaining?
10.
10.
10.
9.9.
What 10 point? Kaza? 10.
Okay.
Mr. I was
Muhammad
gonna
Amir.
say it, but
Fractions and
Okay.
decimal, khalas, math exam finished. Forget the decimal now. You are bringing this decimal here, okay? So, did you understand the reasoning or you didn't understand the reasoning?
Yes, we understand the reason.
The reasoning is you have to focus on the proton first. Forget the neutron. It is the last issue. The first issue is finding proton. And how do you find proton? From the atomic number. And where is atomic number? Given above each element in the periodic table. Now look, I just gave you fluorine example. Now look at oxygen and tell me, in oxygen, tell me the number of electrons, tell me the number of neutrons, tell me the number of protons. And also in nitrogen, tell me this, tell me this, tell me this, and then we are ending today's class. Who will tell me this? Who will tell me this?
What, mister?
can I try
Yes, sir.
telling Mr.
Ma
Muhammad
salama
Ali?
then, ma
No, no,
salama.
خلاص, خلاص. Okay,
Sir,
okay.
can you
okay.
hear me?
Yes, Muhammad Ali.
Can I try?
Okay, I'll give chance to everyone. Okay.
Okay.
So C chance will go to who? To Adnan.
Muhammad
Adnan.
Ali. Oh,
C chance will go to Adnan. What is C? Silicon. E,
Okay.
N. Okay, this one for Amir. Start solving. This one for Ali. This one chlorine for Ibrahim.
Yes.
Because maybe he loves swimming. So in swimming you have chlorine mixed to filter the water. I'm just making weird assumptions. Electron, neutron, proton. And where is Badr? AR, argon. Here is Badr. So this is Badr. So start giving your answers. Who is giving his answers first?
Me.
Ibrahim, go for it. How many electron, how many neutron, how many protons?
Okay, electrons, there's 17 electrons, 17 protons, and 18 neutrons.
Oh, wow. How are you so fast?
Because it's easy, Mister.
Whoa, 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 whoa. Okay, who is coming next?
Me, Mr.
Good.
Me.
Let me start giving emoji.
Okay.
Let me learn something from Badr.
wait, Mr. This is confusing. I don't understand it.
Mashallah, tabarakallah. At least Ibrahim can feel proud today.
Mr. Can I say for you my answer?
Okay, Adnan, go for it. See,
Electron 14, proton 14,
Electron-
neutron 15.
mashallah,
So I
mashallah.
don't understand this.
Okay,
Mr.
I will
Nami, Mr.
let you not understand until the last moment.
Mr. Me now.
I will tease you now. But this is 28 just, not 29, Adam. Oh, Adnan, it's not 29, so your neutron is wrong. It will be 14 also.
Yes.
Oh, wait.
Ibrahim, am I correct? Sir, Ibrahim, am I correct?
Allahu Ya'lam.
Oh, it's correct. Next, who's coming?
Mr. No, me.
Mimi. Yes, Meme guy. Yes, Meme guy.
Electron 7, neutron 7, proton 7. 7. Cristiano Ronaldo.
7.
Oh, so we got a double C, huh? Cristiano here and Cristiano here.
Yes.
MashaAllah.
Okay. Yes, who is
Yeah,
left?
7
Ali and
Me.
Badr. Badr, go for it.
18.
What 18? Shawarma?
Proton.
Huh?
Proton 18.
Proton 18, correct. Very good.
Uh-huh.
And neutron.
Electron, how much?
Electron.
Huh?
18.
18. Neutron? Ting tong,
Neutron.
ting tong, ting tong, ting tong. Yes, how many? Ting tong, 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 ting tong.
Mr. He is laughing. He's not answering.
He's not answering. Okay, I'll answer on his behalf. The answer is 22.
17.
No, not 17. I already gave you the steps.
I kept 17.
22.
Mashallah, very fast.
MashaAllah.
Next, Muhammad Ali.
I did not understand.
Last one.
Okay, what number is given here?
8.
8.
8.
Is this atomic number or mass number?
Atomic.
Atomic number. And the bottom that is given is what?
Mass number.
Mass number. So atomic number means what? The same number of electrons, and to balance them, the same number of positive guys. Clear so far?
Clear.
Yes.
Yeah.
Okay. Now come to the bottom number, which is rounded off is 16.
Hmm.
Now in 16 is what? The nucleus.
Even number.
What
So
even
it's
number?
8. So it's
Mashallah,
8.
yani,
So Mr. Neutron is 8 because like the proton took 8, so it will be 8 then neutron.
exactly. So 16 minus.
So can
Yes, this is the answer.
I try solving
You want
another
one more?
one?
Okay, one last and
Yeah.
then I'm ending. Okay.
Yes. No, Mister, I'll
Okay.
solve it because
You-
you're just so smart, Mister.
No,
Oh,
so
you
I'll
try
solve it.
you try this one, bromine one.
Oh.
Muhammad Ali.
Okay, so it's the number of atoms is 35. So the electrons is 35.
Number of atom is 35. Who said that?
No number of.
Number of
Atomic number,
electrons.
What?
You don't say
Atomic
atomic number as number of atoms. You are changing the whole meaning.
No,
Yani,
the number of
J.J.
electrons.
Thomson, you want to call him Thomson. Atomic
No.
number, you call him number of atomic, and you want to make your own
No,
chemistry.
I
or
meant
what?
35 electrons. 35 electrons.
35 electrons. Okay, then what?
So because because of atom is neutral, so
Mhm.
the proton will be 35 too.
Correct.
And
Correct.
79.9 will simplify to 80.
Okay.
So,
So-
there's 80 minus 35 is the neutral,
How much?
which is 45.
Yes. This is what I wanted to explain. Clear? Oh,
Clear.
clapping stuff, huh? I think that's enough for today.
Yes.
I think. And this is what they explain to you here. Here.
Yes.
Here.
Yes.
Okay. And isotope is a special category. I'll just end my class with isotope. What is isotope? Isotope, I mean, these are like the different versions of the same element. Like what? Look,
Carbon.
carbon can be written as
Carbon monoxide, carbon dioxide, carbon
not
trioxide.
carbon monoxide. That's a compound. You are going somewhere else. That's a
Oh, okay.
compound. I'm talking about element.
Okay.
Carbon
Yeah.
itself contains 6
6.
12 form. Carbon also contains 13 6 form. Carbon also contains 14 6 form.
Ah.
Okay. It means what? This is the mass number
Yes.
and this is the atomic number. Means what? When
It's
you
what-
have same atomic number for an element, but you have different mass number. That is known as isotope. Yani these are the different versions of the same guy. For example, like Pokemon, you have evolution in Pokemon. Yes, you have Pichu, then you have Pikachu, then you have Raichu. You have 3 versions. Okay.
Yeah,
So-
Mr. Like isotopes is like ions, right? Maybe.
Oh.
Like,
Ah.
but maybe in the atomic number, no, and the proton number.
See, what I will tell you. Just learn what I am saying, Yani. If
Okay.
atomic number is 6 means what? The electrons everywhere is 6. Yani this guy also has 6 electrons, this has 6, this has 6. But what about neutron? It is different. Why? Because 12 minus 6 is how much?
6 and 6
6.
plus 6 equals
So you get 6 neutron in the first version. What is the
Yes.
second version? 13 minus 6 is what? 7. You get 7 neutron here. So basically what do you see? Same number of protons, but different number of
neutrons.
neutron. This concept is known as isotope. And not only carbon, there are more isotopes in nature available.
Yani there is no electrons in the isotope.
Who said there is no electron? They did not make a separate table. You want separate table for electron all the time? For
No.
electron? It's
Oh,
obvious
like,
because
okay,
it's
okay.
obvious. Yani 6 positive lazim, so you will have 6 negative.
Yes.
They are not defining everything again and again, but it's obvious that it will have electron. How can you have without electron atom? You cannot. Okay.
Yes.
So that's the end for today.
Okay.
So in isotopes, you can have multiple questions. Okay. What is the definition of isotope? You have to pay attention. In isotope, what is same and what is different? Tell me what is same in 2 isotope and what is different in 2 isotopes. Ibrahim. Oh, he's handling the insects. Maybe yes. So someone else can answer.
Mister,
now
love
now-
my chair. It's okay, Mister.
In isotopes, the atomic number is same, but the mass number is
Different.
different. Okay. That's it for today. Bye bye. Take care. Assalamu alaikum warahmatullah.
So don't forget to upload them, please. The biology,
Biology or chemistry?
both of
Bye.
them, but biology most important.
Because tomorrow you have bio exam.
Yeah.
Yes. Bye, Mister.
Bye bye.
What are those emojis, Ibrahim?
What emoji?